I am Shyama from Department of Economics, Christu Jayanti College, Bangalore. Today I'll be talking you about the econometric problems, and it is one of the subject part of the course Advanced Econometric Analysis for the PG. And after the session, the intended outcome was to understand, the students or the participants will be able to understand the key concepts like regression analysis, endogeneity, heteroscedasticity, autocorrelation and multicollinearity. And heteroscedasticity, let me start with heteroscedasticity. Heteroscedasticity occurs when the variance of the error term in a regression model is not constant across all observations. In simpler terms, it means that some data points have more spread in their errors than others. When heteroscedasticity is present, the standard error of our estimators become unreliable. This leads to the incorrect confidence intervals and p-values, which can make statistical tests misleading. To detect heteroscedasticity, we often use tests like Bruce-Pagan test or White test. Visual inspections such as plotting residuals against fitting values can also help to identify patterns. To address the problem of heteroscedasticity, we can use robust standard errors which adjust for the non-constant variance or to apply the transformation to stabilize the variance. And when we talk about multicollinearity, it occurs when two or more independent variables in a regression model are highly correlated. In other words, they provide redundant information. When multicollinearity is high, it makes it difficult to determine the individual effect of each independent variable on the dependent variable. This leads to large standard errors and unreliable coefficient estimators, and which may flip signs or change drastically with small changes in the data. We can detect multicollinearity by calculating the variance inflation factor, that is VIF, for each variable, and a VIF value above 10 typically indicates high multicollinearity. And the levels can be 1 and 5 as well. To handle this multicollinearity, we can remove or combine highly correlated variables, or we can use the techniques like PCA, that is principal component analysis, to reduce dimensionality. And when we talk about autocorrelation, and it is also known as serial correlation, it happens when the residuals from a regression model are correlated across time or other units. This is common in time series data, and when autocorrelation is present, Euler's estimators remain unbiased but are no longer efficient. This means that the standard errors are underestimated, leading to overly optimistic test statistics. To detect autocorrelation, we use tests like Darwin-Watson test, and we look at the residual plots to check for the pattern over time. And to address autocorrelation, we usually use a method like GLS, or generalized least squares, or add lagged variables in time series model to account for the correlation structure. To wrap up, today we discussed three common econometric problems: heteroscedasticity, multicollinearity and autocorrelation. Each of these can affect our model's reliability if not addressed properly. Identifying and correcting these issues is crucial for making a reliable inference from econometric models. Thank you for joining this session. I hope you found it useful. If you have any queries, you can put it in the chat box. Thank you.